Okay, here we are in Calculus 2. We're going to do section 8.7, and this is numerical integration. And I was just talking to the students here in class, reminding them that I'm really excited about teaching this section because it's a fun application to see most of the stuff that you learn how to, or most of the integrals that you come across in the real world, you can't actually use the cute tricks or the tables even to get the answer to. And so you have to use some sort of numerical method because you want the answer. And so there are two numerical methods that you're going to look at in this section called the Trapezoid Rule and Simpsons Rule. And there are other numerical methods. If you are going on for a math degree, you can actually take a class called numerical analysis, where you learn all different types of methods for really integration. And it's going to rely heavily on a computer. What I'm going to do here is I'm going to show you, you could do this on your calculator, but it's pretty tedious. So I'm going to show you how to do, it just involves a lot of summing and multiplying and that sort of thing. I'm going to show you how to do it in Excel if you want. And I'm also going to show you a website where they've written a program that does it all for you. So it'll make the homework pretty easy if you use that website. And then I'll also, I was going to say, if you want, and I'll just kind of put a link out on the website, if you want, you can actually download a program called the Trapezoid Rule or called the Simpsons Rule from TI, and they will make your calculator do these rules for you. If you're that interested, you can actually get a program that you can run on your calculator that you could type in, or you can download it if you have one of those. If you got a USB, when you bought your computer, your calculator may have come with a wire, and you can link it in. Otherwise, you can just type it in. Okay, so let's go ahead and start in section 8.7. And we're going to look at, the first thing we're going to look at is the trapezoid rule. And so the idea, again, remember, is you want to approximate, and this is not, it doesn't have to be that it's a positive function, but if you want to evaluate an integral from a to b, one way to do it is to split it up into intervals, and it's n subintervals depending on how accurate you want to be, and just find the area and think of them as trapezoids and find the area of these trapezoids. And you may remember the formula for the area of a trapezoid is 1/2 the sum of the parallel bases times the height. So this is like, this distance right here is your height, and these are your parallel bases, y1 and y2. Does that make sense? So that's why they have 1/2 y1 plus y2, and then times the height of the trapezoid if you kind of put it on its side, which of course is just going to be delta x, your change in x. And it turns out that delta x does not have to be the same each time, but it's more work if you don't make it the same. So I kind of recommend that you do. Okay, so it says approximate short stretches of the curve with line segments to approximate the integral of f from a to b. We add the areas of the trapezoids made by joining the ends of the segments to the x-axis. All right, and so they go through some work, and I'm not really going to derive this, but you can read it in your book. If you were to do this over and over again, let's just kind of think about it. This is y naught, right? And this first trapezoid is going to be 1/2 y naught plus y1 times delta x. And the second one is going to be 1/2 y1 plus y2 times delta x. And the third one is going to be 1/2 y2 plus y3 times delta x. So if you think about it, after the first height, after this y naught, the y1 gets used twice because it gets used in this trapezoid, the first trapezoid, and then it also gets used in the second trapezoid. And that's the same for y2. It's going to be used in the second trapezoid and in the third trapezoid. So except for y naught, and it turns out yn, the last one, those y coordinates are going to be used twice. Of course, the 1/2 and the delta x is used on each time. So if you're adding those all up, you could simplify it a bit. You could factor the delta x out. You can divide by 2 because it's 1/2 each time. And then notice you had 2 y1s, 2 y2s, all the way up to the right before the nth one. but you just have one y naught and one yn. Does that sort of make sense to you guys, where that formula comes from? Okay. All right, and so the y's are the values of f at the partition points, and x naught is just your initial value, like on your integral from a to b, it's your a. And then x1 is a plus whatever you decide the width to be. And that width is determined by how many trapezoids you decide to shove in there. So that's your n. So you can get delta x by doing b minus a divided by n. And then x2 then would just be your a plus 2 delta x's and so on. And so they say, you know, x sub n minus 1 would be a plus n minus 1 delta x's. And then finally the last x sub n would be just your b. Okay? Now it turns out there's an approximation for the error in the trapezoid rule, and again, you can read about this in your book where they come up with this, and looking at errors and how accurate your methods are is a common numerical analysis technique. But if f double prime is continuous on m, and m is an upper bound for the values of f of the second derivative from a to b, so you're going to take the second derivative and you're going to maximize it, then the error approximation from a to b for n steps satisfies this inequality. It's always going to be less than or equal to that upper bound times the length of the length of the interval cubed over 12n squared. So that's just a formula I'm not going to go into. If you want to read about it, you can. We're just going to kind of use that formula. I didn't derive it. Okay. All right, before I go into Simpsons Rule, I want to go ahead and work a problem. So let's look at this example. And I picked an easy example that we can just do by hand to kind of get you to see how this program, how it works. But, you know, it wasn't too rough. Okay, so first of all, it says evaluate the integral directly. Well, that's easy enough. This will just be 10 to the 4th over 4 plus 10 squared over 2. And we're going to evaluate that between 0 and 2. And so this is going to be 2 to the 4th over 4 plus 2 squared over 2. Then, of course, when you plug 0 in, you're just going to get 0. And so this is 4 plus 2, which is equal to 6. Okay? And so then now we're going to try using the trapezoid rule to estimate the integral with n equals 4 steps, and we're going to find the error. Okay? So the trapezoid rule, what you're going to have to do is split up your interval. Okay, let's just first kind of think about what we have. We have A is 0. We have B is 2. We know that N is 4. And we know that delta X is equal to B minus A over N. So in this case, it's going to be 2 over 4, which is 1/2. Oops. Okay. All right, and so what we're going to have to do is split up our interval. Since our interval goes from 0 to 2 and we're counting by halves, you're going to want to do 1/2, 1, 3/2, and 2, right? And you're going to need to find the coordinating function values at each of these, at 0, and then at 1/2, and then at 1, and then at 3/2, and then at 2. And those are going to be the values that you plug in. Those are your different y values that you're going to plug in right here. Okay? So this isn't that hard to do by hand, but I want to model it in Excel just to kind of show you how you can automate it a little bit. Okay, so let me get the computer going. so I'm going to switch over to this computer. So this is 2007, but it does all the same. It just looks a little bit different up on the top here, but otherwise it's the same. You'll see it okay? Okay, so what I'm going to do is I'm going to go ahead and input my A, and you know, just to kind of keep yourself straight, you might just want to put A, B, N, and then, you know, you could say del X, and these are just kind of, if you were going to change it each time, just sort of to keep your mind. And then each time the A and the B and the N are going to be different, so we'll do A is going to be 0, B, they told us on this one, was going to be 2, N was going to be 4. All right, so the first little formula that you can create is delta X. Remember, delta X is B minus A divided by N. So when you want to do a formula in Excel, you go up to this little box right up here where it's called the formula bar, and you put your cursor there and see how it's flashing. And then in order to input a formula, you start by putting an equal sign. So I'll do an equal sign, and then now this will be in formula mode. So I need to do the difference between what I have in cell B3 and B2, because that would be B minus A, divided by what I have in cell B4. So I'm going to do that in parentheses. I'm going to do B3 minus, so I just had to move over it and click on it. I'm going to do minus, and then I'll move over and click on B2, and then I'll close that parenthesis, and then I'll say divided by, so I'll just do the division symbol, Bn, which is in B4, and then if I hit enter, it'll do that for me. Okay, so you guys have seen that before, or you think that's pretty cool? All right, now the function you might want to go ahead and put in there, or you could even call it y or f of x or whatever. The function here is and actually you're not going to want to, sorry. You might want to just remind yourself what it is, but never mind. You're okay. Sorry. What you're going to want to do then is get your different x values. So you're going to have your x and then your f of x. Okay, that's how we want to do it. Okay, so to find our x, we want to start, where do we start? We start at, right, A, right? We start at A. So I'm going to say, I'm going to put an equal sign. I'm going to put that right there, B2, because that's A. Okay, which of course is 0 on this one. But see, the idea is I'm trying to automate it a little bit, so for the next one I won't have to change so much of it. Okay, now to get to the next coordinate, what do I have to do? Well, I have to add delta x to the previous one, right? So I can say equals, and then you could take what was in this one, D3, and then add delta x. Hit enter. Now, it should recognize the pattern where, and I'm going to do this, and I'm not quite sure, but do y'all see how it gets, like, you have choices in your cursor, like, looking at my cursor, do you see how it's a big daddy, this a big fat plus sign? Do y'all see that? But if you move it kind of really close to that corner, it becomes, I call it mama, and it's a little skinnier. See how it's skinnier? Then if you click and drag, it'll fill that same formula in, but it's not doing exactly what I want, because what it did, like, notice this one was D3 plus B5. This one, though, what I want it to be is D4 plus, I always want it to add just delta x, right, so B5. But notice it did D4 plus B6. Well, there's nothing in B6. So does anybody remember how to fix a value? I don't know. How much Excel have y'all had?
A couple of, like 2 or 3.
That's one way to do it. But if you want it to fix a particular value, if you use a $ in front of both the... Right, I don't know. But if you use a $ in front of both the row and the column, then that will be fixed. So what I'll do is I'm going to change this to a $sign here and a $sign there. Okay, now it'll still say 0.5, but when I grab mommy here, hopefully it changed it to 1. Do you see how it did that? And so let's see if I can pull it down some more and if it'll fill it in. Yeah, and it got to 2. So it's just doing what I want, which is taking the previous one and adding the delta x. Everybody okay? Okay. All right, and so then now, how am I going to get the function value? Well, what I'm going to want to do is take the value that's in x and put it into the function. So I'll do equals, and then I actually am going to have to put the function in, which is t cubed plus t squared. So it's going to be this cell cubed plus this cell squared. And then I just hit enter, and then I should be able to fill down, and it should work. So this one, it did the D4, and then that. You can check this. This would be 1 cubed plus 1 squared, which is 2. So you're feeling pretty good. Okay, so those are all your y values. Everybody okay? All right, and so then finally, to get your trapezoid formula, to get your answer with the trapezoid rule, and this little program that I wrote is only going to work if n equals 4, but I think on almost all your homework they want n to be 4. Now, because you'll have to change it if it, if they wanted n to be 8 or 12. But I found a program online that you just put what you want n to be. So this is just kind of an idea of how to do it. All right. Okay, so with the trapezoid rule tells us to take delta x and divide it by 2, and then multiply that by the first y value plus 2 times the second y value, and really it's 2 onto all of them up until the last one. So you could do, you could put a parenthesis right here, and then you could do a plus this one plus this one, and then just plus the last y value, which is this one, and hit, close your parenthesis, and then hit enter. Oh, didn't like it. I don't know what my error was. Do y'all see the error? I needed a times right there, and it went ahead and fixed that for me. So that was a mistake. If you want multiplication, you have to say multiplication. You can't just do right next to each other. So say yes. And so then you get the answer of 7, which if the true value is 6, we're a little bit off, aren't we? Wasn't that fun? Isn't this just totally great? Okay, let me show you, and all it did then was just make that computation. So let me show you back to the laptop, this website. I wonder, I didn't get. I haven't signed in on this computer yet. Okay. All right, and so what you do is you have to enter the function. You do the left endpoint, the right endpoint, and then the number of subdivisions that you want, and then have it do the rules. Okay, so this is. So you're going to do x cubed plus x and your left endpoint was 0 and your right endpoint was 2 and you wanted 4 subdivisions, right? And we'll try the trapezoid.
X4 to the 4th.
Pardon?
X to the 4th.
No, you shouldn't integrate. Oh. So this makes me think that I did something wrong on my program.
I wrote it down.
Well, when we originally, it was TQ plus T. Pardon?
I wrote it down.
Oh, okay. Now I get to, I can't believe I'm recording all this and I have a mistake. It really makes me think that there's something going on wrong in my computer program. But let me see. In what I did, because I'm sure that's more accurate than me. Let me just check this column and make sure that it's right. You should take your, let's see. So, let me see. There's the mistake right there. The actual problem did not have a squared in it. I'm sorry. It was just t cubed plus t. So there's my mistake. Yay. Okay, like that better. Okay, and so then all I have to do to fix that is go like this. And then, see, it was like I made the mistake to model how fun things can be. Sorry. Okay, so, no. That's why I like computer science. You have to be so careful. I can mess it up. All right, I'm sorry. I have no excuse. But anyway, yeah, if you don't input the function correctly, you're garbage in and it's garbage out. That's the first lesson. All right, and it's always nice to have something to check it with. So it turns out that this little program is fun. So you can use this program or you can do it, practice with Excel if you want. Either way is fine with me. Do you kind of get the gist of, even though I had that mistake, did you get the gist of what I was doing? I was just applying the formula. Okay, good. Sorry about the mistake. Okay, so let's go now. And then, again, this is, and I'll put this in another place on the website too, but this is in your notes. You can click on it from there. Okay, so we got the answer to be 6.25. 6.25. Now it says, but we also want to find E of t. They want us to calculate E of t. Which is an estimate for your error. So if you come up here and you look at this formula, they tell you that it's less than or equal to m times b minus a cubed over 12n squared. We don't actually have to use this formula, though, because we were able to calculate the true value, right? The true value was 6, and the actual value was, the estimated value was 6.25. So we know our error here was just the difference between these two. So the error is the difference between the approximate and the true, which is 0.25. But we'll come back to that formula in a minute, because the whole idea is that you use the trapezoid rule. It doesn't make any sense to use the trapezoid rule on a problem that you could have worked by hand. You do it on one that you can't work by hand, and so then you would only be able to get an estimate for the error. So this is the most that the error will be. All right, so let's come in here. And so we got it to be, 0.25. And then it says, use the formula absolute value of E of t divided by the true value times 100 to express the error as a percentage of the integral's true value. So what you do is you take E of t, which is 0.25, and divide that by the true value, which is 6, and multiply that by 100, and you should get 4%. So you have a 4% error. And of course, how could you reduce that error? Well, if you had, if you increased your number of n. Okay. All right. So the other method, besides the trapezoid rule, is called Simpsons Rule. And the idea behind Simpsons Rule is that instead of trapezoids, you could fit cute little parabolas in underneath your curves, and you could find the area under the parabola. And if you go through here, you can actually find a formula for the area, and all they do here, what they're doing, they're just kind of deriving the formula. You can actually find a formula for the area under a parabola, a generic parabola for a given interval, right? Because you can just call it ax squared plus bx plus c, and you can integrate that from negative h to h. You can do the algebra, and you can get a formula for the area. Do y'all agree with that? Okay. And so it turns out if you do a bunch of those calculations, you find the formula. If you do that calculation, you find that formula to be h over 3 times y naught plus 4 times y1 plus y2. And you can look at page 593 of your textbook if you want to see where that comes from. Well, after a little thinking about shoving a bunch of parabolas in there, you will find that Simpsons rule is to do delta x over 3 times the first value, y naught, plus 4 times the second value, plus 2 times the third, 4, 2, 4. And so it alternates like that, 4, 2, 4, and continues on in that way. And the y values, the y's are the values of f at the partition points, just like before. And your delta x is still b minus a over n. Now, it does require that n be even because it used actually it uses two problems here. It's working with two rectangles there originally. So n has to be even. And then you also have an error estimate to compute for Simpsons rule as well. Okay, so let's try using, oops, I guess I should have answered number 2. I'll come back to that one in just a second. Let's try use Simpsons rule to estimate the integral with n equals 4 steps and find E of s. I'll come back to this question in a minute. Okay, so Simpsons rule to estimate the integral with n equals 4 steps and also to find the error, which in this case all we have to do is just look at the difference. So what we're going to do is we're going to go back to our Excel, and we'll try using Simpsons rule. So if you look, we're still going to need all of these numbers. So this was actually kind of like your trapezoid rule answer. So you could call it like the trap answer. And then we also need a Simpsons rule approximation. Maybe approx would be better, but anyway, we'll try. Okay. Now, to do Simpsons rule, we do delta x over 3. So we're going to say equals, and then we'll say delta x, which was this one, divided by 3. and then times, and then parenthesis, and it's y naught, which is the first one, and then plus 4 times the second one, plus 2 times the third one, plus 4 times the second one, the next one, and then plus the last one. So it alternates 4, 2, 4, 2 until you get to the last one. Okay? So we do the first one and the last one, and in the middle it's 4, 2, 4, and then since you have an even number, it always ends on a 4. Okay? And then close that parenthesis. Do we feel good? All right, let's try it. So, 6. Feels pretty good, doesn't it? Simpsons rules can be much more accurate. All right, so let's try, let's go to the little website, and let's leave it the same, but instead of hitting the word trapezoid sum, we'll say Simpsons Rule, right? And it gives, oops, you didn't see that. It was really cool, too. All right, I hit Simpsons Rule, and it changed my answer to 6. I don't know how good this is recording anyway. For y'all. Because I had everything else I needed. So it's a great little website. It's just doing the work for me. Probably a lot more elegantly written program. Okay, and it's free. Should we give credit to whoever it is? Thank you, Stefan Bonner and Stephen Constantinople. All right. Okay. So we notice that with Simpsons Rule, we got the error, we got answer equal to 6, and so E of S was equal to 0 there, right? And so our E sub S means error for Simpson, right? Was actually 0 on this one. Okay, so now another type of question that you're going to be asked on the homework is to estimate a minimum number of subintervals that you'll need for a approximate error. Okay, and so that's when you're going to you're going to use this formula, these formulas. So you want to use this formula, E of t is less than or equal to m times b minus a cubed over 12n squared. And you want that to be within the 10 to the negative 4. Okay, so if you're looking for n, what you can do is you can solve this problem, you can solve this equation for n. So we will solve this for n. And I'm just going to do it real quickly. If we would cross multiply, and then we would take the square, and we would divide by e of t, and we would take the square root. Are y'all feeling that? So you could multiply both sides by n squared, and then divide this side by e of t, and then you would just take the square root, and that would solve that equation for n. So n would need to be equal to the square root of m times b minus a cubed over 12, and then you have that e of t because you divide it by. Okay? All right, and so this will give you an estimate for m, and you're always going to, if it's a decimal, you just go up, you know, because it's estimate for n. So you're just going to go up. All right, so let's figure out what values we have. I know that b is 2, and a equals 0. I know that they want the magnitude to be less than 10 to the negative 4. So e of t is 10 to the negative 4. That's how accurate I want it to be. Tenths, hundredths, thousandths, tenths. They want it to be the nearest 10,000. That's what they're saying. All right, and then we need to get this m. Well, m is the max of the second derivative. Okay? So to find m, you maximize f double prime. Okay, well, f of x is that our original integrand, which was the t cubed plus t. So I guess it's f of t. And so the first derivative is 3t squared plus 1, and then the second derivative is just 6t. Okay? All right, so on the interval from 0 to 2, what is the max? You can do it. You can do it. This is a line. 6t is a line. Yes, there it is. And so the maximum value, you don't have to take the derivative, set it equals 0. I mean, you can if you want, but if you're having a good day, you would say, oh, wait, this function's always increasing, so the maximum value would just be at 2. You know, when x is 2 or t is 2, that'll be 12. 6 times 2. Yeah, it's not a hard question. Yeah, you don't want to be wrong in front of, have it be on video forever. Unlike me, who I've already set the stage for mistakes, so you should be. Okay. All right, so now we have everything we need to get n. N is going to be the square root of 12 times b minus a, which is 2 minus 0, cubed over 12 times 10 to the negative 4. And if you type this into your calculator, yeah, you can cancel those 10s, and it's 8 cubed over 10 to the negative, cancel those 12s. It's 8 cubed over 10 to the negative 4, which is approximately, if you type this in, 282.84, or you want to let n equal 283. Because you can't have, n is the number of subintervals, so you can't have, a decimal number of subintervals. I'll just check this with my calculator. Yeah, and just remember that when you type it in, if you're going to do a product in your denominator, you have to do it in its own set of parentheses. You guys know that by now, probably. But anyway, that works fine. So that's a lot, right? So if you went here, I don't even know if it'll do it. And if I change this then to 283, I wonder how long it'll take or if it'll even do it. Oh, it does. Notice, look did you see how fast that is? Thank you, Stefan and Stephen. Oh, they're like German and English. Stefan and Stephen. Y'all rock. Okay, notice, tenths, hundredths, thousandths, 10,000. See how it's almost exactly 6. It's to the nearest 10,000. It's to 10 to the negative 4, the error, right? It's only off by 0.00049, so it's really good. Does that make sense? Yeah? Okay. Now, Simpsons Rule, it was accurate at 4. Do you remember that? Because when I put 4 in here, and I used Simpsons Rule, I got 6, which was the true value. And so I wonder, could I use even less than that? Now remember, Simpsons Rule requires n to be even, so my only option, less than 4, would be to only have 2 rectangles, or 2 subintervals, and it turns out that if I put a 2 in there, and then do Simpsons Rule, it's also 6. Okay, so let me show you the math behind that. Okay. To estimate the number of subintervals needed using Simpsons Rule to approximate the integral with an error of magnitude less than 10 to the negative 4, well, if you look at Simpson's error formula, m is an upper bound for the values of the fourth derivative, the absolute value of the fourth derivative. Well, our function, what is our fourth derivative? Yeah, because the third derivative was 6, and the fourth derivative is 0, right? So this is equal to m for Simpsons rule. So we could use this formula. Well, I mean, it doesn't make sense for n to be 0 because then you wouldn't be using Simpsons rule. So when you get a fourth derivative of 0, then n can just be 2. So n can equal 2 because it must be even. Okay? So that covers a lot of the homework. You have to do, it's a bunch of different functions, but you have to do all this stuff. And I'm okay if you use that cool website or if you want to write a little Excel program. It doesn't matter to me. And then as you get further into the homework, you start to have to find the minimum number of subintervals. So that gets you, that's what I did, is I covered those questions on here. And then the next sort of thing that you do is they give you, oh gosh, can you read that? Let me see if I can make it a little bigger. They give you tabulated values of the integrand to estimate the integral with either the Trapezoid Rule, Simpsons Rule, and they tell you n equals 8. Round your answer to 5 decimal places, and then find the integral's exact value and approximate e of t or e of s as appropriate. Okay, so this is not actually that hard, but this is definitely one that I would use Excel with because I don't want to have to like type all this stuff into my calculator, you know. So what I would do here is I would come in and I would be kind of snazzy. Let me look at the problem again. The problem, it's starting at 0 and it goes to 1, and notice your delta x is b minus a over n. So what you could do is if you come in here and you're, okay, on this. So what I'm going to do is, I wonder if you can make that bigger. Is that better? Yeah. Okay, so I'm going to, the b is 0, the a is 0, the b is 1 on this one, but our n is 8. See how things change automatically? Isn't that cool? Yes, Ms. Brooks, I know. All right, now I'm going to delete these guys because they're not going to work, and I'm going to delete these guys because my function is different, right? But what I have here are, it's doing all the different pieces, and so I should be able to get the mommy and drag down to 1, which is exactly what is on the problems. See, if you go to the laptop, you'll see the values are matching to what I had. See, from 0.125, 0.25. Okay, now you could type the numbers in that they give you in the table, but that wouldn't be very cool, would it? The cool thing to do would be to go ahead and input the formula. So you're going to do equals, and then it's this one, and then times, and then in Excel, square root is SQRT, I think. I'm pretty sure. And then you're going to do parenthesis, 1 minus this squared, and then close the parenthesis and hit enter, and then you're going to pull that down. Okay? And that it turns out that it's accurate to the same number of decimal places as was on the problem, but you're probably going to want to force that. Otherwise, you may get just a little bit off, you know, when you're typing it into the computer. So to make sure that this is rounding to what you want, highlight the area, do a right click, and then do format cells, and under number, select number, and it was 1, 2, 3, 4, 5 to 5 decimal places, which is what you were already seeing, but you don't want it to remember any of the other decimals either. You want it to truncate them or cut it off at 5, okay? Okay, all right, and so then now what do we have to do? we want to use Simpsons Rule and the Trapezoid Rule to find our answers. So how will I do that? What will I need to do? For Simpsons Rule, or let's do Trapezoid first. How do we do Trapezoid's Rule? We do, it was delta x divided by 2, right? So this divided by 2, wait, how do I get it to be a formula? Equal sign, and then I do this divided by 2, and then times, and then parenthesis, and then the first value, right, plus, and then it's 2 of all the other ones until the last one. So I'm going to do 2 times, and then I'm going to do, you can actually be really snazzy. If you want to be totally cool, you can do a parenthesis here, and then you can type the word sum, and then a parenthesis, and then you put it on where you want, and then all the way down to what you want. So the sum of these, right? Then close that parenthesis, and then what? Yeah, then you add the last one, and then you close that parenthesis, and then you hit enter. Okay, and so see, you could do it by hand with your calculator, but all those decimals typing in would be not fun, right? Okay, and so then Simpsons Rule, you're going to do an equals, and Simpsons Rule was delta x divided by 3, so you're going to do this value divided by 3, and then times parenthesis, and it went, the first number, this one you have to do it. You have to type each one in. So it does get kind of tedious, and you could, if you were snazzier than me, you could probably come up with an algorithm to make it work, so each time you don't have to change the n. Like they have, their n is incrementing, and it's a lot cooler. Their program's a lot cooler than mine. All right, so I'm going to do this one plus, and then it goes 4, I forgot. Yeah, 4, 2, 4, 2 until you get to the last one. So you're going to do, oops, let's see, 4 times this one plus 2 times this one plus 4 times this one plus 2 times this one plus 4 times this one plus 2 times this one plus 4 times this one plus the last one. And then you close your parentheses. Okay? Everybody feel okay? And then you hit enter, and you notice that it does appear to be a little bit more accurate.
I guess you could just do 2 of those some formulas and separate out your 2s and 4s.
Yeah, you could. Yeah, you can be snazzy, see, and I want you to be creative like that. However you know, there's a lot of ways to think about how you could simplify this. Now, we could, let's remember those numbers. If we come over here, let me go to the laptop. We come in here. Okay, we got, with the trapezoid, we got it to be 0.31929. 929. And with Simpsons, we got it to be 0.32812. Now, we can go to our cool website and change this. And I didn't practice. I should have practiced this. But I'm guessing that I'll do x times, I think it's probably going to be SQRT also. So SQRT, shift, parenthesis. I forgot, what was it, 1 minus x squared? Yeah, 1 minus x squared. 1 minus x, shift, squared. And they'll, like, see here it says take a look here for examples of function formatting, so you could always click there if you wanted. I think it's probably square root. I'm living on the edge. Okay. Now we wanted, what was our interval on this one? Well, it was from 0 to 1. And we wanted the number of subdivisions to be 8. That was our n. And then we're going to try this. I'm so nervous because I should have practiced this ahead of time. Are y'all nervous? You don't care. 0.3. Oh, look. Yay. Go me. Okay, 0.31. Can you even see it? I don't know. Anyway, it is what I got when I used the trapezoid rule. And so then if I want, I can just hit Simpsons Rule, and I do get the other number. So maybe it's easier just to use this computer program. But it's kind of fun to think about Excel again. Okay, so then that was the first thing they want you to do. It says round your answers to 5 decimal places, which you did. Then find the integral's exact value and approximate the error. So we actually get to do this by hand. How are we going to integrate the integral from 0 to 1 x on the square root of 1 minus x squared dx? Right, we're going to use a u substitution. Spin spring break. All right, and so then du is going to equal negative 2x dx, right? I did u equals 1 minus x squared. All right, and so I'm going to need a negative 1/2 in the front. It has been spring break for me too, so watch out. All right, I'm going to integrate. If I put 0 in for x, I'm going to go from 1 to 0. So this is where, I think last time somebody asked me if I could take this negative off and go from 0 to 1, and that is correct. And then it's u to the 1/2 power, du, which is add 1 to the exponent, put it over. So negative 1/2 times 2/3 u to the 3/2 evaluated from 1 to 0. So the answer, of course, is going to be positive 1/3, which is 0.3 repeating, right? So to 5 decimal places, it's 1, 2, 3, 4, 5. So we're only accurate to 1 decimal place using 8 subintervals. So find the integral's exact value and approximate the error e of t and e of s. So how do I find e of t? It's just the difference between the actual and what you got with the trapezoid rule. So you're going to do 0.33333 minus 0.31929 to get your answer. Which is 0.01404, and E of S 0.12345 minus 0.32812, which is 0.00521. Okay? And so if you wanted, you could come in here and you could mess. Like if you wanted it to be even more accurate, you could change this to like, if you made this like 14, I wonder how that would change Simpsons Rule. You know, it gets a little closer. See how it's getting to 0.3, but it is taking some work to get there. Okay. All right. Last problem is looking at the volume of water in a swimming pool. It says a rectangular swimming pool is 30 feet wide and 50 feet long. The table shows the depth, h of x, of the water at 5-foot intervals from one end of the pool to the other. Estimate the volume of the water of the pool using the trapezoid rule with n equal 10 applied to the integral. Notice on this integral, when I first did it, I just added up, or I just used the trapezoids on these heights, and I forgot to notice that it's multiplied by 30. So your final answer is going to be multiplied by 30 because that's the something about the volume, or because it's 30 feet wide. Okay, so you're just going to fill in you're going to want to, again, you got to go from, notice you're going from 0 to 50 on the x's. Now, there's no pattern on this because they're actually measuring it. There's no pattern for the h, there's no function, right? So you're just going to have to input each of these into your Excel, or if you did it by hand, you'd have to type them in. But I still think I would do it with Excel. So I'm going to show you just how to do that. So this one, it's your delta x is going to be, you're going to go from 0 to 50, and your delta x is 10. And your n is 10, which makes your delta x 5. It's going to count by 5. So notice how it did that for you. It doesn't like this because it's unhappy there. But we need to get to 50, so I'm going to extend this a little more. Grab the mommy and pull it down, right? Okay, and then here you're just going to type in the numbers that they give you. Which I guess they're measuring. Okay, and notice it's doing it to 5 decimal places because I had forced that before. Okay, and then they want us to use the trapezoid rule, but it is 30 times it because in the formula they multiply by the width. So just remember that you're going to take your answer and multiply by 30. So you'll just do the equal sign here, and it's delta x divided by 2, and then times the first one plus 2 times the sum of these plus the last one, and then hit enter, and that's that, and then you multiply that by 30, so you could say equals this one times 30 to get the estimate of the volume. Okay? So just kind of a fun little activity working through these problems. Maybe, I don't know. You like it? It's not so bad. You like that website? Yeah, okay. I'm sorry the homework, there's so many problems on the homework, but I think you'll be okay because you haven't, yeah, with the website, you're not going to hurt my feelings if you just knock it out that way. It's more just understanding the process. So I will see you guys next time.